Welcome back. In the last chapter, we made the model, our AI expert, the brain that knows how to look at images and understand them. We learned how to load a pre-trained expert using YOLO class and ask it to analyze a single image. But what if the pre-trained expert is not quite right for a specific task? Maybe you want to detect objects it was not trained on, like a rare type of flower, or recognize different types of defects on a factory line. In these cases, you need to train your custom expert by using your own data. You can make your own data set. So training a model is like teaching a student. A student needs a textbooks, lectures, and practice exams to learn. In the world of AI, the model needs data, specifically a collection of images and their corresponding answers or labels. This collection of data is what we call a data set. So this will be explored in chapter 2, data set. So really, what is a data set? Think you can think it is alternatives as a comprehensive set of study materials for your AI model. So it is a collection of images as well as the labels for training the models. So it depends what model wants to recognize. So it includes images. Images are the pictures the model will learn from and be tested on. These are the textbooks. Whereas labels, these are the ground truth information about what is in the each image. For object detection, this means telling the model where the objects are using the boxes or the marks. So and what they are by using the class name. These are the answers key or the practice exam solutions. Just like students need different materials for studying, like training versus testing their knowledge, because first you prepare before the exam, you prepare in your home or in your college by using different textbooks and examples, but in the final exam or while in the exam you are being tested. Just like that, similar scenario happens in this computer vision as well. So for this, a data set is typically split into two sections. One is three sections, sorry. So one is a training set, which is the largest part we use for the model to learn from, like studying textbooks and doing homework. Whereas another is a validation set. So for example, when used during the training to check the model's progress. So for example, you read from the textbook and you try to remember or you try to solve the problem, different problem. So you practice one problem using the example, and at home you do another problem, similar problem, for the validation whether you know or not. It helps to fine tune how it learns without letting it cheat by looking at the test data, like taking occasional quizzes as well to see what you have learned so far. Whereas test set is used only after training is complete to get a final unbiased measure of how well the model performs on new data it has never seen, like taking the final exam. So organizing these images and labels correctly is super important. If the model cannot find the right image or match it with the right label, it can't learn effectively. So what if the pre-trained expert is not quite right for your specific task? That is an important question. But you need to organize your study materials, which is a dataset structure. So for example, Alterytics, it expects your dataset to be organized in a specific way because it needs to understand that. Because the algorithm is written in a way that we must follow the order, so that it can easily find all the images and labels for the training and testing. So for example, we have our custom data set. Inside it we have image folder, which includes train validation folders and which are later constituting their images, respective images. Correspondingly, similar folders as well as the images are present for the labels as well. So, but the exact structure, it can vary slightly depending on the task, like detection, classification, or segmentation. But there is a common pattern for tasks like object detection. So for example, for object detection, we have highlighted this section. So inside labels folder, each image has corresponding .txt file with the same name but .txt extension. You can see the file name is same. This talking about this image 1 jpg, its information or label will be presented or be passed by using this file .txt. This file contains the labels for that specific image. For object detection, each line in the text file usually represents one object and contains some important thing like class index like 1, 2, and its center point in the x coordinate and y coordinate, as well as the image width and height. So for example, we will be providing the centroid or center of the image coordinates x and y, as well as the width and height. These numbers are typically normalized between 0 and 1, however, so to in the relative image dimension. As I mentioned, class index will also be presented there, which will be the number like 0 for car, 1 for person, like that. Now we'll be talking about the dataset blueprint, which is the .yaml file. So what is a data.yaml file? So for example, to tell Ultralytics where to find our structured dataset and what the classes and names mean, we should create a simple configuration file usually named data.yaml. It is the root of our dataset directory and it must be presented at the root or somewhere which is easily accessible. So for example, I have presented the example from the website, which includes .yaml file, which provides the location of the train images, validation and testing, as well as names. And for the RoboFlow, it has provided the workspace. It will be using Llama model, what is the project name and the version, as well as the URL. So this is a simple example as well. So for example, if we see in our left image, we can see a simple YAML file for our custom data set, which might look like this. So where train and validation are the path for the training and validation image folders. These paths are usually relative to where the data.yaml file is, or the relative to the path specified if we include it. So for example, you can see the YANSI, which is the number of classes in your data set. So we are taking the example of car and people. So there are 2 classes, so we'll be passing 2, and we are providing the names as well. So in this order, the index 0, 1, as we know in Python, the first index is 0 and second index is 1. Therefore, when we pass this dictionary or list, so then what will happen is the car will take the 0 index and person will take the 1 index. This data YAML file is like the dataset ID card and or a map. So it will tell Ultralytics everything it needs to know to access and understand our study materials. We will be learning about the configuration file later as well. So talking about putting the dataset to work, training model. So how does Ultralytics use this dataset? While the nitty-gritty details of the trainer are in the later chapter, like in a trainer, the key idea is that when you tell a model to train, you point it to the data.yaml file. In the previous chapter, we use model equals to something like this function to load a pre-trained model, right? This is having something pre-trained weights and something like that. To train the model on our custom data set, we need to create our train method and specify the data set using the data argument. So for example, we have data, so we are replacing our actual images, actual path, or the YAML file. So for example, this results we see this is the command, right? Model the train is the command to start the training process. This data argument is where we give the model the location of our data.yaml file. So we see the structure of YAML file before in the previous slide. This analytics would read this file, understands our dataset structure, the number of classes it has, their names and all, and it then uses the information throughout the training process, loading the image and labels from our specified folders, or if we give the ebooks, I think I have not provided ebooks here. So if we give the ebooks, it will know to train on the how many cycles. So for example, if I provide the ebooks of 10, then it will be trained for 10 cycles throughout the entire training data set. So if we look the how the data set is used, we can see this is a really complex process. However, when we call a model.train, the analytics engine, specifically the part related to trainer, does not just load all images into memory at once, because it will consume so much RAM. Instead, it will set up the special objects that know how to load data as needed during the training. So we can see here there are different ways, like use a Python script which is calling the model for the training. Before we were just loading .pt file, but now we are calling the train, because we are going to train by using our custom data set. And when we call the YOLO, by using the YOLO class, when you call the train model.train function, it will initialize the training process. So for that, the trainer component, it needs the access of the YAML file, and which will read this path data.yaml file, and which will return back the dataset configuration like image path, classes, as we mentioned earlier. And then this dataset abstraction, it will pass the dataset object like train dataset and the validation dataset, everything. Then the magic happened, right? Then the magic will happen. It will request a batch of data, it will load and labels from the train validation folder, and this process will happen. So as I mentioned, first base data we provide the fundamental capabilities like finding image files, applying the common image transformation like resizing, potentially catching images in the memory for the faster access as well. So we also have this base data set. This data set we have this dataset abstraction. In the diagram, it represents two dataset. One is a base dataset and another is YOLO dataset. As I mentioned, base dataset provides the fundamental capabilities, whereas a specific class like YOLO dataset, it builds upon base dataset and it adds logic specific to the task label format. For example, YOLO dataset knows how to read those lines. For example, we have talked about coordinate like center, x, y, or even the height and width. It understand, or YOLO dataset will know how to read between these lines, and it will prepare them in a format that model understand for object detection training. So there is also classification dataset which knows how to use the folder names themselves as labels. Now these dataset objects work behind the scenes, like loading and preparing data efficiently in batches for the trainer in order to feed the model. So you don't usually interact directly with a YOLO dataset or base dataset as a beginner, because this everything will be handled by our model.train function, as shown here, model.train function, and it handles it for you when you provide this data.yaml. So now don't look all these things, we only are targeting this dataset abstraction. So these codes are also available in this GitHub repository. This contains the logic for reading image files, parsing this annotation based on the task, and applying the data augmentation. Augmentation means you are doing the random transformation of image, either you are rotating, flipping, or doing something crazy like noising them or sharpening them, in order to make sure that model understands certain variation of that image. So I think this is a conclusion for our dataset chapter. We are not going in depth because this is just the introduction lectures. So in this chapter we learned that the dataset is essentially study material like images and labels, which are needed to train our own custom AI model. So we know that organizing this data into train and validation and optionally into the test splits with corresponding images as well as our labels folders, typically following the YOLO format for the detection task. So this data.yaml file acts as a centered configuration pointing alternatives into our data, defining our classes. Finally, we also see that using this data set for training is as simple as providing data.yaml. So we see here it is very simple to call the function and everything will be done inside, right? This is like a black box. So understanding the dataset concept and its required structure is a fundamental steps to our training models, specifically tailored to our own problems. So for example, if we are going to uh, do work on the model to detect different construction and demolition waste, it can be tailored specifically for that activities. Now that we know that this data, what this data is and how to structure it, now we'll look at some useful tools within Analytics that can help us manage and work with our data as well as the models in the next chapter. So we'll be talking about the utilities in the coming chapter. Stay tuned. Thank you.